Welcome back, everybody. This video is going to cover probability. So the probability unit, you should be rounding answers to the nearest 10,000th or 4 decimal places or reducing a fraction. Remember, we should not be writing it as a percentage unless we are asked for a percentage. So first example is going to be experimental versus theoretical. So if we take a 6-sided die, which we've all seen before, you've got a 1, a 2, a 3, a 4, a 5, and a 6. So there are 6 sides to the die, and what we're going to do is come up with a theoretical probability of rolling a 6. Well, only 1 out of the 6 sides is a 6. So theoretically, your probability is 1/6. Or we can call that 0.1667. Remember, round to 4 decimal places if you choose a decimal, or we can write 1/6. Now the experimental part. So the experimental part is, what if you just took one die and rolled it 20 times? And we got a 6 8 times. Theoretically, our probability is still 1 in 6. But experimentally, that showed up 8 times in 20 rolls, which of course we would reduce to 2/5. Or we could say that that's 0.4. So the difference between these two is theoretical is you roll a die one time, you have a 1 in 6 chance of getting any number on that die. But an experiment, those are the results of an actual experiment. I mean, if you were the luckiest person in the world, you rolled it 20 times, you could get a 6 all 20 times. Does that mean theoretically every time you roll a die you're going to get a 6? No, it's not. So experiment is just the results of your experiment. Theoretical is without even rolling it. You should know that the probability of getting any one of those numbers is 1 in 6. So this next example is going to be the difference between independent and dependent. So what's the probability that you select a blue, replace it, and then select another blue? Well, you have to obviously know that there are 20 marbles in the bag. 10 of them are blue. So we have 10 out of 20 for the first try. And independent and dependent, that's the multiplication formula. So, but this time we put it back after the first pull, and now you still have 20 marbles in the bag, and 10 of them are still blue. So the second marble you pull is still 10 out of 20. So we multiply, that'll give us 100 out of 400, which we know reduces to 1/4, or 0.25. And that one was independent, because the first thing did not affect the second thing. So if you replace something, it's independent. The next example is dependent, because we're going to find the probability that you select a purple, set it aside, and then select another purple. So let's imagine this bag of 20 marbles, and we know that 3 of them are purple. So we have 3 out of 20 marbles times, now remember, set that purple aside. You now only have 19 marbles left in the bag, and only 2 of them are purple, because we just put this other purple marble aside. So he's no longer in there. Multiply those two guys together, and you should end up with 6 out of 380, which would reduce to 3/190, or 0.0158. And the difference between independent and dependent. Independent means you do 2 things and they don't affect one another. Dependent means the first thing that took place had an effect on the second thing that's about to take place. Like when we set the purple marble aside, the first thing we did now changed our possible outcomes, because there's only 19 marbles left and only 2 of them were still purple. Next example covers overlapping and disjoint. So overlapping is when they have things in common. And disjoint means they have absolutely nothing to do with one another. So if we take a standard 52 card deck, what's the probability that you get a face card or an ace? So remember, the formula for or, if they are disjoint, is we just add the 2 probabilities. So the probability of a face card, we know that there are 4 suits. There's jacks, queens, and kings in each. So we have 12 face cards out of 52 total cards in the deck. Plus an ace. We have 4 aces out of a total of 52 cards in the deck. And there's no overlap because an ace is not a face card. So that is equal to, and we just add those together. So that would be 16 out of 52. Which means the probability is 4 out of 13, or 0.3077. But what's the probability that you select a red or a 4? So let's think about reds. Out of 52 cards, there are 13 hearts and 13 diamonds, which means we have 26, or half the deck is red, and the other half is black. Plus a 4. Well, we have a 4 of hearts, diamonds, spades, and clubs, so we have 4 4s in a deck. But this is where the overlap comes in. Remember, we have 26 red cards, and we have a 4 of hearts, we have a 4 of diamonds, and then we have the 4 of spades, and the 4 of clubs. So out of those 26 red cards, 2 of them are 4. So that's where the overlap comes in, because we have to subtract those, otherwise you're counting them twice. So we have to subtract the 2 overlapping cards out of 52. Okay, so then all we have to do is do 26 plus 4 minus 2. That's going to give us 28 out of 52. So that means there is a 7 in 13, or 0.5385 chance. Okay? And the difference, of course, is what we said. Disjoint means they have absolutely nothing to do with one another. But overlapping means that some of them fit into both categories, like the 4 of hearts and the 4 of diamonds. It belongs to the group of 4s, and it also belongs to the group of reds, so you have to subtract your overlap. Next section is permutations versus combinations. Remember, permutation order matters, and combinations, it doesn't, which makes your locker combination weird. So if we have 8 horses, how many different ways can 3 horses finish in first, second, or third? So with that type of question, does the order matter? Yes, if it didn't, then you wouldn't have a horse finishing in first place, and then another one finishing in second place, and then the third one finishing in third place. So the order in which the horses cross the line does matter. So yes, it does. So when order matters, it's a permutation. So for a permutation, it's just 8 permutate 3, and you just use your calculator. Under the probability menu, you have that NPR. Just make sure your N is 8 and your R is 3. And you should end up with 336. And in the next example, which I'd made with the same numbers, but it's slightly different because we're going to just choose 3 out of 8 possible toppings to create a pizza. So does it matter if you put the sausage on before the pepperoni, or does the pepperoni have to go first? It doesn't matter. So as long as you end up with a pizza with the 3 toppings you want on it, who cares which order they put them on? So in this case, no, it doesn't matter. So that means if order doesn't matter, we're going to choose 3. And if we type that in the calculator, we're going to get 56. Okay? So a lot less than the one above, because in this case, the order doesn't matter. All right? Finally, the last one. Now this is where you need your calculator to draw or to come up with a binomial distribution. But we have a survey of 75% of students. They study for their final exams. So we're going to randomly ask 6. So in your calculator, remember, it depends on how your calculator works. But we're going to have to do a binomial distribution. So remember, in L1, you have to do your 0. Don't forget your 0. And then you have your 1, 2, 3, 4, 5, and 6. And then for L2, that's where you highlight L2 and you have to press that second and then the distribution button. And you have to go to binomial PDF. And that's where you have to type in your 6 and your 75% success rate. And when you click enter, it'll automatically populate all of L2 for you. And remember, the calculator does things in different ways, so make sure you know how to use your calculator. So then you would have your 0, 1, 2, 3, 4, 5, and 6. And I'm not going to draw a whole bunch of boxes right now very accurately. I just want to make sure that we have enough time to get through this video. But what you would do then is look at all of your binomial and the binomial results that you get, and you would sketch a little bit more of an accurate graph than I'm doing here right here. Like I said, I just want to make sure that we get through this video. And you would just round to the nearest 4 decimal places like the directions said. So for this guy, the probability of 0 would be 0.0003. And then we had 0.0044, and your calculator is going to have the rest of these for you. 0.0330, 0.1318, 0.2966, 0.3560, and finally 0.1780. And that's what you get from your calculator. And what we're going to do is just interpret those results. So what's the most likely outcome? So if we were to walk up to 6 random students and say, are you going to study for your finals? The most likely outcome is 5. 5 students study. What's the probability that at most 3? So at most means 3 students are going to say it. So that means we have to add our results for 0, 1, 2, and 3. And if you were to add all of those up, you should end up with something like 0.2091. And when it says at least 4 students, that means 4 is the least. So 4, 5, or 6 students say, I'm going to study. Add those results up, and you should be at 0.8306. All right, so this video covers the probability unit. This is Longo, and I'm out. See you, bye.